Hello, we are in Algebra 2, Chapter 7, Section 4. This is page 4, the final page of these notes. Okay, we've got these graphs. We've got some graphs to make. We've got log base 2 of x and log base 1/3 of x. I mean, I can hardly contain my excitement. So let's do part A. We have log base 2 of x. Boom. Let's get to graphing. Okay, it says plot several convenient points such as, and now this is where it becomes more obnoxious. Okay, in exponential graphs, it's easy enough. You graph 0, comma something and 1, comma something. Logarithm graphs, not so easy. First of all, 0 doesn't work. It just simply doesn't work. 1 does work because 1 is always 0. Log base 2 of 1 is 0. Log base anything of 1 is 0. Boom. 0. Happiness. Now for the next x value, they chose 2, and it's a very smart choice, and the reason why is it's the same as the base of the exponent. Smart thinking that. Make your next x value be the same as the base of the exponent. I could not emphasize that enough. That is so important. Because then when you plug that 2 in for x, you get log base 2 of 2, and that's 1, because 2 to the 1 is 2. Boom, 1. And 4, comma, I'm not sure why they chose to have a third point, but hey, no harm. They cheated. They squared the base. Boom, squared the base. So it's going to be 4, comma 2, because 2 squared is 4. The y-axis is a vertical asymptote. So I'm going to go here, make myself a vertical asymptote on the y-axis. Okay, you've got the point 1, comma 0. Dot me up. All right, you have the point 2, comma 1. Dot, dot, dot. And then the point 4, comma 2. Dot. All right, we have a curve that starts just to the right of the y-axis and moves up through the plotted points. So arrows on the end, please, please, always arrows on the end. Boom. Okay. Part B. Y equals log base 1/3 of x. Okay, so the first spot is going to be x equals 1, and the y value is 0. Did I mention the y value is always 0 when you plug in 1? Yeah, it's true. And then you have 3. Now, I think I told you to use the base, but this time because the base is smaller than 1, it's a little annoying. So here's what you do. You cheat and you use the upside down base, because 3 is going to have the y value -1. 1/3 to the -1 is 3. And then 9, comma -2, because 1/3 to the -2 is 9. The y-axis is a vertical asymptote. The y-axis always starts as a vertical asymptote. So boom, boom, boom over here. I'm going to asymptote it up. Put arrows. I don't know why I put arrows on the asymptote. Doesn't matter. 1, comma 0. They changed the scale apparently just to see if you're slightly awake. I'm not really sure. 3, comma -1. And then 9, comma negative. Okay, 4, 6, 8, 9, comma -2. I guess that's why they changed the x scale, but I guess you have to be awake. All right. From left to right, draw a curve that starts just to the right of the y-axis and moves down through the plotted points. So, oops. Oh yeah, there we go. And that's your graph. Now that's all for example 5. It's going to get more interesting. Oh, look at that. So we have example 6. Y equals log base 3 x minus 1 plus 2. Okay, here we get to work. We've got this adding and subtracting business going on. Let it go for now. First suggestion is just graph y equals log base 3 of x. So this, not looking at the graph they asked for, but the simpler version, it's going to be 1, 0, 3, 1, and 9, 2. That's because 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9. Bingo. Okay, so 1, 0. Did that thing with the x-axis again, didn't they? Okay, 3, 1, 9, 2. Boom. Now, I'm going to go ahead. I'm going to draw that asymptote because of what's going to happen next. And then arrows on the end of the graph, please, please. Okay. Now, translate the parent graph. It does not mean change the language. It means move. Move the parent graph. Check this out. -1, that means write 1 because it's inside the function. Also, for bonus, it's in parentheses, and everything inside the function, definitely the stuff in parentheses, it goes the wrong way. So -1 inside means write 1. +2 outside, that means go up 2. So we're going to go write 1 and up 2. The translated graph passes through. Let's see here. If you go write 1, you had 1, 0, and you moved right 1, you got to 2. You had 0, you go up 2, goes to 2. 2, 2. 4, 3. And it's going to be 9, 4. Excuse me, 10, 4. So at the point 2, 2, got the point 3, 3. I'm sorry, 4, 3. And the point 10, 4. It says the graph's asymptote is, here's the thing. When you move the graph right 1, the asymptote also moves right 1, except I messed up because I didn't notice the scale. So the asymptote is now at 1. And then you draw the same type of shape of graph. You got to go through your new points. Looks like I missed my point slightly here, so boom, boom, arrow, boom, boom, arrow. The graph's asymptote is, it's a vertical line now, so it's x equals 1. You moved right 1. The moving up and down did not change the asymptote. It's the moving right and left that matters. This is exactly the opposite stuff that mattered compared to the last unit because it's an inverse function. The domain is x is greater than 1 this time because it moved right 1. And the range is all real numbers. Boom. Did I mention the range is all real numbers? The range is always all real numbers for logarithm graphs. Finally, this checkpoint. You know what? I would normally say give yourself a chance, try it on your own, but they changed the base to a base that's below, that's 1/2 now. I think it's a little too weird. If you want to try it on your own, fine. I'll still pause for a few seconds so you can pause the video and try it. But if this one looks a little too intimidating at first, there's no shame there. Okay, so I'm assuming you didn't pause the video. If you did, I'm sorry. You'll have to bear with me. So, recommended you start with y equals log base 1/2 of x, and that's going to help because you're going to have the point 1, 0. When x is 1, the y value is always 0. You're going to have the point 2, -1 because 2 to the negative, excuse me, so sorry, because 1/2 to the negative 1 equals 2. And you're going to have the point 4 comma negative 2. So I'm going to plot those points. I got the point 1 comma 0. Got the point 2 comma 1. 2 comma negative 1. And 4 comma negative 2. And we have this general logarithm shape. It's the it actually is an upside down looking log graph, and it is, but it's because the base is smaller than 1. Drew the asymptote in for fun, because next we're going to do y equals log base 1/2 of x minus 3. Now, nothing happens inside the logarithm this time, so the only change is the graph shifts down 3. So, the points. We had 1, 0. We have 1, negative 3. We had 2, negative 1. We have 2, negative 4. And we had 4, negative 2. We have 4, negative 5. So, going back to those points, we have 1, negative 3. We have 2, negative 4. And we have 4, negative 5. All the points have been moved down 3. Because there was no movement right or left, the asymptote stays the same. And so the graph looks essentially like that. So the blue graph is the final graph. I can't really circle the graph well, so I'll circle the blue stuff I wrote on the side. That's the actual graph. We still need to do domain and range. So domain is x is greater than 0. The asymptote did not shift, so the domain is the same as a basic domain is. And the range is, I hope you filled it out already, all real numbers. The range of every logarithm graph is always all real numbers. That is the final end of this work. Thank you so much for watching.